Okay. Today we will set up a lab, okay, for the Terraform. So using Terraform, we will set up a entire data center, like a set up a fully functional VPC, fully functional VPC, then launching EC2. If we have time, then we can deploy some application as well, okay, some sample application, like HD, a web application, okay. So these are things that we are going to cover today using Terraform. So this is from scratch, okay. We will do everything from scratch, like downloading. I think I downloaded that AWS CLI and Terraform on my local machine. Then the rest of thing, yesterday we discussed like we have an AWS account, right? So we need to take that user secret key and private key, I mean access key. So those are the things that we cover today. So before that, I will show you the dependencies. Okay, you got the scenario, right? All of you.
Yeah.
So first we need to download Terraform. So Terraform. I already downloaded and set up. Okay, so I will show you how to do that. So from here we can download Terraform. So this is the official website for the Terraform, and came here and select the operating system. Okay, if we have using Mac OS, then we need to go with the Mac corresponding mm, commands or selecting the respective package. Okay, so for Windows we need to go with the Windows download options there. For 368, also AMD 64, both have different package. For Linux, we can go with the command lines. So using wget, we need to take in that package and install on the Linux machines. This is for Ubuntu, CentOS, Fedora, Amazon Linux, Homebrew. So I already downloaded for Windows. Okay. Then next thing is AWS CLI. So this is a official documentation from AWS. So here we can see the package, AWS install and update updation. So here if we are using Linux, then we need to go with the command here specified. Okay. Then for Mac OS also here, and for Windows, we need to download the MSC file, this one. So click on the link and it will automatically download that MSI package. Then we need to run that on our local machine. So here you can see after download. mm, See, this is the package. Okay, the zip file we can see, and open the zip file. We can see the Terraform file here. So this is the executable file for Terraform, and then we need to open. Okay, after downloading both, we need to open environment variable. See, edit the system environment variable. Open and go to environment variable.
No, I can't. We can't see it actually.
Wait, give me a second. Okay, type environment variable. Here we can see edit the system environment variable. Click on that. And here we can see come to the advanced source, advanced option and go to environment variables. So here we can see path. Go to the path. Okay. So click on the path. And here actually we need to provide the path of our downloaded packages path. Okay. So here you can see Terraform. This is already I configured here. So this is the my Terraform path. So I need to click on the new, then provide the path here, like copy the path from see from here we need to copy the path. This one is enough. Don't go for the zip file. Okay, we need to. This is a exe file. So take this file and rest of the path we need to copy and provide it here. The same thing I define here. My Terraform executable file under the downloads. That's all. There is a zip file there, but I extract the zip, okay, on the same folder. That's why I'm provided here. For the same AWS CLI, I provided the AWS CLI configuration here. AWS CLI we need to install, okay. It's a exe file, so we need to install. Whenever we install, that corresponding package goes to C program file, Amazon, like this file we got. So we need to provide that corresponding path. Got it. So that's the basic configuration of setuping Terraform and AWS CLI. Then we can open with any text editor. I will go with the Visual Studio Code. Then open a terminal here. Okay. This is a terminal, similar like PowerShell or CMD. And we need to type that commands for the Terraform and Terraform. See, Terraform is working fine. Also AWS CLI. We can type AWS command as well, AWS configure. So it will looking for, see, it will asking for the AWS access key. So that's fine. So both command line tools or both tools working fine on this specific machine. Then we can go with the rest of process.
We have to install VS Code to write.
Yes. Installing Visual Studio Code is easy, just to type Visual Studio Code. That's all.
I know. Whatever you are using is VS Code.
Right. So this is option to install Visual Studio Code. If we use Visual Studio Code, we have a lot of feature because we can add for coming to DevOps, we can add a lot of extensions. Okay, like for Terraform, Docker, Kubernetes. See, we can integrate with the accounts. I mean, cloud providers. That's good actually. So that's fine. Now we need to start a project, right? So coming to starting a project, I mean the project for setting a VPC and the rest of thing, we need to write that Terraform configuration file. Then we need to provide it here. Okay. The best practice is we need to create a folder. So here we need to create a folder. Okay, that's fine. Then we need to open file. Coming to Visual Studio Code, open file, then open a folder. See, then we need to define the folder that we created. That's the best practice, because whenever we starting a project, our all the files belongs to a specific folder. Okay, that's that. See, click on the project. Also here you can see whenever we switching. Okay, I mean open the corresponding project, that command line directory will change. Okay, change to the respective new folder. I'm selecting Terraform and select folder. That's all. Now I am opening terminal again. See where I am. I am switching to the corresponding folder. So in that folder, nothing there. So also here you can see we are in the Terraform project. This is a folder. So from the same folder, we can what we can create file. So this is the option to create file, create folder. So I'm going to create a file under the folder Terraform. So first I will provide the provider.tf. Okay, provider.tf. Hit enter. So now you can see on the right side, open that specific file. And here we need to provide the provider.tf. So that we will get from AWS provider.tf. This is official documentation. Okay. So from here, we will get that latest command. So this is a command. Copy back to here and provide it here. So that's fine. So we now successfully define that provider that we are going to use AWS. So everything we tell to Terraform. Now, after copy paste here, we need to save that configuration. Okay, so go to file again and click save. Now we go back to the project. Okay, so here you can see. So this is a folder that we created. So here you can see the file is created here. So what file we configure or saved in that Visual Studio Code. So all the files belongs to the same, or it will save on the same folder. Okay. Now we are going to create another folder, sorry, another file. So in this file, we need to keep our main configuration. Okay, main.tf. You can name it as main.tf. Tender. And here we need to provide that command.
So the file name should be provider.tf and main.tf, right?
No. Any name we can provide. But
Then
that
how
format.
come Terraform will know whether, if it is like we say abc.tf, how come the Terraform knows that the provider is AWS, which is defined in ABC? How does it gonna recognize?
No, we already defined that. So coming to here, this is a provider.tf. Okay, it's fine. So when coming to the configuration, okay, the commands AWS recognize that is for the specific for provider.
So
Got it.
name convention, we can give anything.
Yes, we can include that provider.tf inside the main.tf as well. So don't need to define a provider.tf. But this
Okay.
is the best practice, and we can easily know, okay, this is for the provider and this is for the main.tf like that.
Okay.
So this is the a main.tf sample file. Okay, show you. So here you can see this is main.tf file. Okay, so the main.tf file starting with resources. So yesterday we discussed it's defined as resource type, and resource name. See, so we are defining a resource using Terraform. So Terraform now we define a resource, and that resource is AWS VPC. So this is the way we define AWS VPC in Terraform. Okay, this is unique actually. So this way we need to specify AWS underscore VPC. So for another resource, you can see AWS underscore subnet, AWS underscore internet gateway. Similar way we need to define the resource. Okay. So coming to the first block, okay, this is the first block. So first we need to define a resource, then we need to define that this is a format, okay. After resource type and resource name. This is a name for the tracking of Terraform only, okay. This name does not visible in the console. Console we can see this is a name. Under the tag we can see the name for the specific resource. So this is only for Terraform tracking. And we need to open a curly base. Inside the curly, we need to define the rest of things. How we will manually configure a VPC, same way we need to define the IP address for the specific VPC and the tag. I mean the naming. Got it. So it will create a VPC, just a VPC. Okay. Then we need to configure the rest of thing to set up that specific VPC, a fully functional VPC. For that, we need to provide. I mean, we need to create subnet, root table, internet gateway, and a lot of stuff. The same way we need to define another resources that is AWS subnet. Then for the tracking, we can give any name. Okay, so here I only provide the main. So don't confuse that. Then open a curly. Then we need to define how this subnet will communicate or connected with the above VPC. Because whenever we creating a subnet, so I'm going to create a VPC. Okay, so click on the VPC, create VPC. See the tag we already provided. Okay, and that IP. Then click create. So it will create a VPC. Same thing we define here. The tag provided, IP provided. Also, the source we define as AWPC. So it will create a VPC. Then the next thing is subnet creation. So click on the subnet and create subnet. So first we need to select the VPC, right? For creation, creating subnet, we need to define the VPC. So select the VPC like default or anything. Then we need to provide the name, availability zone, then the IP address for the specific subnet. So same thing we need to define here for the subnet creation. So we need to define the VPC ID. Okay, this is a VPC ID. So AWS VPC, that's a resource for the specific Terraform for AWS. Okay, AWS underscore VPC. Then main dot ID. So that's a name. I told you that we created a AWS VPC, and for tracking Terraform, we define the name main. So here you can see how we will connecting with the specific VPC, that is AWS underscore VPC dot main dot ID. That means this specific sub under the VPC that we created above. Then we need to define the IP for the subnet. So this is a subnet for the IP subnet. And same series. It's 1.0.24. Okay. Then it must. Then mapping public API on launch. That is true. That means there's option for the subnet. Okay. Public API assigning. So this set as true. Then availability zone US East 1. I'm using US East 1 region. So under the US East 1, 1A, that's a availability zone. Then the name for the subnet, public subnet. Then coming to AWS, internal gateway. So we need to create another resource, internal gateway, give it a name, main. And whenever we creating AWS internal gateway, we need to define or we need to attach that internal gateway to the specific VPC, right? So here you can see VPC ID, set the VPC ID, okay, AWS VPC dot main dot ID. So it will goes to the VPC that we created here. Also naming tag IGW, internal gateway. Similar way, we need to create another resource for the root table. And coming to root table, we need to define the VPC. So VPC defined. Then the root. For root, we open a curly here and 000. Everyone can access. We need to define the gateway, internet gateway. That means we make that the root table or the subnet public, okay? Because you can see the root we define here. This is the destination and this is a target. And create a name, sample root table. Then root table association. Whenever we create a root table, then we need to associate that specific root table with the corresponding subnet, right? Otherwise, the subnet will remain same. No routing anything happen. So we need to associate. So for association, we need to create an association, and we need to define the subnet, which subnet that we are going to associate. So same subnet we need to define here, AWS subnet dot main dot. So here you can see this subnet. The tracking name is main. Okay. So in real world scenario, we don't define this main all where. Okay. So we need to define corresponding name. So for example, if the VPC has ABC, then we need to define here as well ABC. I mean, when coming to the ID, same way we need to define the corresponding name. For the subnet, we can choose DDD. Then we need to define the same name. So root table we defined. This is the AWS root table association. Okay. Subnet ID defined. Whenever we go with the root table association, we need to define that corresponding subnet which associate for the root table. So we need to define that subnet. Also, we need to define the root table, which root table that going to associate with the corresponding subnet. So in this block, that subnet association completed. Then we created a separate security group. Okay. Then we will attach that security group to our machine. So these all things enough for creating a fully functional VPC. The rest of thing we create a mission and security group. So here you can see we create a resource that is for AWS security group, name as WebSG. Whenever we creating a AWS security group, we need to define the VPC. So here you can see we define the VPC that we created above. Then whenever we define or creating a security group, we need to define incoming and outbound, outgoing traffic. Okay. So incoming means ingress and egress means outgoing. So for ingress, we open the port number 80. So who can access? Everyone can access 000. And we define that HTTP description as allow HTTP. Then protocol TCP. Open the port 80. Then coming to egress, mostly egress, we open all the port. Okay. That's why here you can see for outgoing traffic from the machine to the world, we open all the ports. The name for the security group. Then coming to machine
What is
creation.
the protocol in the protocol -1? What does it indicate? Which protocol? Outgoing.
Minus one, this one, right?
Hmm?
So whenever we configuring outbound traffic, okay, we open all the ports from 0 to 65. So in that case, we can't define the specific protocol, right? Even it's a TCP or UDP or anything. That's why it's mentioned as dash one. Got it. In above, you can see
Yeah,
only we
TCP.
open a specific port 80 and we can define that TCP. TCP, UDP there. So in this case, we don't define any specific protocol because we open that all the ports like 0 to 65,535 or something port we open for outgoing.
For real time, do we open all the ports? Instead, we have to open specific ports, right? For
This is
incoming and
outgoing.
for outgoing, it will be same for in the like real world too. And I mean, in your job.
Yeah, we need to close actually. That's all the requirement actually. For this is
Mhm.
the easy to measure. Okay. So this is internet. Okay. So coming to the port, around 65,536 or something. Okay. Then that much port there. So this same port using for incoming and outgoing from the specific machine. Ports are belongs to these are the logical ports. Okay. Logical for running specific services. So these port from the machine and to the machine actually. So for example, okay, give me a second. Okay. Uh, so yeah. So if you open all the ports, okay, for the incoming port, going. So for the incoming, we called as ingress. That's another name for the incoming, okay. And this is for the outgoing egress. So if you open ingress, okay, in this case, we open the port number 80 only. So the logical port number 80 open. So anyone can access our machine via port number 80. Port number 80 or we specific for the HTTP, okay, HTTP protocol. Using the HTTP service using the port protocol TCP. Two types of protocols there, right? TCP and UDP. User data protocol and transition control protocol. That's a full form of. So this is one of the protocol that we use for I mean backend there is a handshake happen. Okay, handshake. That's a handshake process. Handshake because two entities there. Okay, one and two. So using TCP, there is a handshake. After the handshake, they will send the data to one to two. So first it authenticate you to the corresponding machine and so okay, then yep, I will send the data and it will acknowledge the data as well using the handshake. Finally, there is acknowledgement. So the sender knows, yeah, all the data will send it to the second entity. Entity means machines, okay? One machine and second machine. Coming to UDP, there is no handshake or acknowledgement. They will send the data continuously, sending. If that the destination mission missing and data that is missing. That's all. That's the difference between TCP and UDP. So coming to TCP, it will when comparing with the UDP, the data transfer speed is less, okay, because there is a handshaking process, acknowledging process, so it will take some time. So UDP there is nothing, so it will send fastly. For video streaming, so all the video streamings using UDP, like live video stream. And so, yep, here we open the port number 80. That means only we can access the machine using the port number 80. So the hackers can't use our machines, right? So for example, if we open all the ports, then hackers can easily access our machine using the open ports, unused ports like that. So if you open outgoing port, okay, or here you can see we opened all the ports for the outgoing. That means from this mission to any of the service, okay, that's actually it means. So no one can attack our mission if you open all the ports, outgoing ports. So some other reason, for example, coming to organization perspective, okay, so organization gave us laptop, right? So in that case, they will close some outbound port number. That means, so whenever I am using my official company laptop. For example, I'm trying to access 9,000, okay, the port number for the specific mission. Okay. I mean, I installed SonarQube in my mission. Okay, also not in my mission, SonarQube in a cloud mission. And I opened that cloud mission 9,000 port, okay. But from my company mission, I can't access 9,000. That means for the specific mission, that company locked my outbound traffic 9,000. So they will restrict for the outbound as well in some cases. So that's one of the scenario. Whenever we launching EC2 mission, all the ports are open, outgoing ports. So if we need to close, then we need to close. Otherwise, for example, in my company laptop, if I am using 9,000, that means they will open the port number, all the port number open. So they will restrict. That's why the same scenario we need to follow, okay, coming to outbound. Got it.
Got it.
So coming to here, yep. So that's fine. Now we need to define the machine configuration. AWS underscore instance. That's the keyword that we use for defining AWS EC2 machine. Then the name. Then AMI. Coming to machine configuration, we need to define the AMI. So this is the AMI. We need to check the AMIs. Okay, available AMIs. First, we need to go to the corresponding region. Then go to the EC2 mission. Because whenever we changing the regions, that AMI will change. Okay. So now I am in US, North Virginia. Select the EC2 instance. So launch instance. And here we need to define, if we select any of the operating system, then we need to copy the AMI ID from here. See. So if I am going to AWS, Amazon Linux, then copy the ID to create the specific Amazon mission. So here we can see is used on 86. Exchange rate, copy. Now I am renaming, sorry, rechange the IMA ID. That's fine. Then we need to define the instance T2 micro instance type. Same thing we need to define here. Then subnet. Networking. Under the networking, we need to define the subnet. Subnet defined. Security group. Key. In this case, we need to define an existing key, okay? Then associate public IP. The same thing. This one, auto assign public IP. That is true. So we will get a public IP for the social machine. So these all things to create a machine using Terraform. Then same way we defined a user data. Okay, this is a user data that we included in the script. So the user data, how we will define the user data? See, this is a machine configuration page. Okay, manually in this is a user data part. So here we can paste the same thing. Okay, whenever we go to manually use copy this all and put it here. That means whenever the machine reloaded, okay, booting after the booting, it will looking for the user data. So this is a script actually, a bash script. So it will execute the commands yum update, then install HTTP web server, then starting the service, enabling service, then echo something. Okay. So using echo command, we create a simple HTML page and the content is allowed Terraform HTTP server, and it will save to the directory where actually we keeping the index file, okay, var www.html. Then tagging for the machine sample web server. Then a output we define here. So it will output the easy to machine public IP. The value and description there. So these all things in for the specific configuration. Copy. Here. Okay. And save. Now we need to run the commands. Before that, I will show you how to create a user and the stuff thing. Go to IAM. And go to the user because we configure AWS CLI, right? So we need to provide the necessary user credentials there whenever we typing AWS configure. So here you can see a lot of users are there. So I will go with one of the user test Terraform, okay, or Terraform user. That's fine. So I'm selecting one of the user and scroll down. So here you can see what are the permission for the specific user. Administrator access and some EKS cluster S3 access. That's fine. Then we need to go to the security credential for the specific user. Okay, go to security credentials, and here you can see the access key. I already created access key, but I missed that, so I will go to delete. Delete. First, we need to deactivate the account. Okay, then only can delete. Yes. So that is deleted. Okay, that specific access key deleted. Now we are going to create a access key to count, and we can go to the use case as others. Next, create access key. See, this is access key and this is a secret key. We can download the CSV file as well, so that keys are saved in our local machine. Now I am copying the access key. Okay, copy the access key and go back to terminal. Now first we need to type AWS configure. That's a command. Okay, AWS command. Hit enter. So it will ask you for the access key. So copy the access key that paste the access key that we copied. Then go back to copy the secret key as well. Copy. Hit enter. Then it will ask you for the region where we'll provide US East 1. In cache, before I use the same region. Okay, that's why we can see the region like this. Retender. Then this is a default output format. Okay. So format we can define like JSON format or anything, or else we can leave it as a retender. Now the configuration part is completed for the AWS CLI. That means the specific user configuration we provided in our local machine, so that specific user can access or managing our AWS account without logging the AWS account. Got it. Now we are good to run that Terraform lifecycle commands, that is Terraform init, plan, and apply. So first I'm going to run the Terraform initializing command. Okay. So it will download the specific modules and set up in the working directory init. Hit enter. So whenever we running the Terraform init command, ensure that we are corresponding directory. So in the directory, you can see we keeping the main file and provide.tf. Otherwise, the Terraform can't access the files. Okay. Terraform init. So it will take some time to downloading the necessary plugins and set up in the working infra. See, it's completed. Now here we can see green color Terraform has been successfully initialized. That means we can try running Terraform plan to see any changes like that. We can go with the rest of the commands. Okay. Otherwise, we will face some errors like red color errors we can facing here. Now we are good to run the Terraform plan command. Terraform plan. Hit enter. So this is the planning phase. Okay. So we can reviewing what are things that we are going to create. So here you can see plan 7 items added. So go above, you can see this is the plan part. Okay. So here we can see we are going to create a AMI. We need to cross check if everything seems same. Then user data, inter gateway, route table. Only the specific or provided things will listed here. Okay, under the plan. Whenever we are trying the plan, route table, VPC, everything will be here. So we can review the section, and if everything is good, then we can go with the apply. Otherwise, we need to change accordingly. Terraform. Now I am going to apply the same. Okay, apply. Hit enter.
Spelling is wrong.
Yes, spelling is. Confirmation type as. See, it's starting to creating VPC. Now we can check, go and check. Before I think I have 4 VPC or something like that. Now it's 5. See how fastly it's creating sample VPC. This is the one. So it's yeah, everything like completed that VPC part, right? Yeah, everything is completed. So copy the public IP. It will take some time. Okay, in background. Actually, the machine is booted. Now it's starting to run that bash. I mean the command, the user data command, installation of Apache. Yeah, it's completed. See how fast we created a ender VPC, I mean the fully functional VPC, and set up a web server. I mean installing Apache. So that's why we using Terraform. So we can check all the things, okay, like so the VPC completed and subnet. Better we can go with the sample VPC route map, resource map, okay. So here we can see all the stuff. So the VPC created public subnet, route table there, inter gateway there. So these all things for the fully functional VPC. And go to the EC2 mission, we can see the EC2 mission instance, sample web server. Got it. So for the same, Terraform will automatically create a state file. Okay. Did you check? Anyone check that? See, or else go back to the mission Terraform. Okay. So this is the Terraform folder, okay, that we created. So here you can see Terraform state file. This is the state file that we keeping, I mean, storing. This is automatically creating file. Okay. You can check the file as well. So these are the configuration of our existing or current infrastructure that including the entire VPC and the single machine. This is a JSON format actually. We can see all the data here, okay, that each data for that entire infra. I lost my internet connection, okay. I'm audible, right?
Yes, you
Yes.
are.
Okay. So I changed some mail, okay, that content, and I will try to apply it again, okay. So whenever we're trying to adding anything in our existing infrastructure, okay, Terraform will automatically refreshing that all that stuff that we created, okay. So here we can see what are the changes that we made. One to change, see, one to change. So also we can see the change. Need to check. User data changed, see, the old version and new version. We can see that what are things that we made, but some changes on the user data. So that Terraform identified that. So the Terraform only apply the user data, okay. Terraform. This is not creating anything, okay. This is a refreshing state only. See, it's modifying the AWS instance web. Because only the made happen on the machine, right? We made some user data. What actually happened right now is changing the content of our website. Okay, there is a index.html file there, so it will changing that content. If permission everything is good, it will change. Yes.
How can we change the infrastructure like from T2
Infrastructure.
to T2 large or something like that? Uh,
Yes.
how is it going to work?
So at that time, it will automatically stop the mission and scale up the mission.
Okay, it will stop, right?
Right.
Okay. So it is not advisable to go in that route.
No, no, no.
Maybe the horizontal podding we have to go.
Right. So that's why it's stopping the mission.
Mhm.
One changed. V2 is not reflected here. Okay, that we can check on the coming class. Okay, rest of thing I will include the coming class. Like this is a basic, I mean, high level overview of how to set up a uh, set up a infrastructure using Terraform. Then we need to learn rest of thing like Terraform modules, Terraform variables, and similar things on coming section. Is that fine?
Okay.
Yeah, that's fine.
Okay. Is there any doubt for today's section? All good, right?
So when coming to access keys, we don't need to delete the older ones. Rather, we can create the new ones, right?
Well, yeah, that's why we saved that specific access key and secret key.
No, that's what you already have an access key over there. So you don't need to delete that one. Rather, you can create the new one.
Right. Or else we need to create another user and provide corresponding, permissions. Got it.
Okay. So we need to
Now yeah.
destroy.
Now I'm going to destroy the things that we created. Okay. So it will destroying all the stuff is created, like the starting with the last created one. That means the web server, then deleting the rest of thing. Reverse. Yes. Now it's starting to deletion. Now we can check the ECD console. We can see the machine is going to shutdown state.
I do see that the Terraform in the VS Code.
Sorry.
Can you go to VS Code once?
Okay, Shadney. Yeah.
So I do see like Terraform backup and Terraform log.hcl.
See, state file and backup file there.
What does Terraform log.hcl do or contain?
That's a temporary file it will create whenever we perform anything. So now it's gone. See. So at that time, that specific content or that state file or the file is locked. So it will only we can see at the time of we perform anything like destroying or creating like that. So all the stuff that we created is deleted, destroyed. See. So coming to the VPC, we can see the only four VPC there. So that's why we use Terraform. We can delete and run, setting infrastructure quickly within a single command. Also, we can manage and we can update our infrastructure using the same way.
Okay.
Got it.
Mm-hmm.
Can you do a lab for the same? I will share the task, okay, for the weekend. I think you are do that AWS, Jenkins CACD, right? That task I put it on yesterday
No,
on
I
chat.
didn't. I have to do it actually.
Hope
I
you
didn't
all
check.
get some time on the weekend, right?
Yeah. I'm gonna do that actually.
Okay, then I will add one more task for the Terraform. Okay.
Mm-hmm.
So whenever you got free time, just try to set up. I think you worked on Terraform before, right?
No. I didn't work on Terraform actually. I have a experience with CloudFormation.
Okay. Got it.
So I have a quick question actually. When when we have a Terraform, why do the companies go for cloud formation related to AWS and Azure something and GCP something, which is costing, um, it's going to cost, right? Wherein the Terraform is open source. Is the
Right.
integration part is something maybe difficult to integrate the Terraform with the AWS? Or I
No,
don't know. Then how come they're not using the Terraform, rather they are going for the cloud formation?
that's because the company has their own policy sometimes, so they will prefer cloud formation because so as a employee, okay, we switching right company. So for example, now we are working in a company.
I know what you're going to say, but the thing is like, is there going to be any benefit of using the cloud formation or Terraform when we are completely hosting our services on AWS?
No benefit.
Everything, no benefit, right? It's the same thing.
Both are same actually, but the format is different. That's all. We do
Okay.
the same thing, right?
Yeah. Cloud formation too is the same thing. We're gonna do the same thing.
Whenever we set up in the EKS cluster, you remember EKS, we manually using EKS ETL.
Hmm. UKCTL, yeah.
Using EKS ETL, we set up the Kubernetes cluster, manage a Kubernetes cluster. That's actually in backend.
It
The
is
cloud formation is used.
using cloud formation, yes.
Right.
And it
So
is
it will take that EKS
creating the
stack
stack.
and
Yeah.
these are the stacks actually for different cluster.
Yes.
But we don't bother about the stack because we use EKCTL tool. So EKCTL's tool leveraging the CloudFormation stack to set up the cluster. It's
Okay.
actually an automation, but we don't bother about the stack in that case.
Yeah.
So the tool is leveraging CloudFormation.
Agree.
So all good, right?
Yeah, I'm good. Thank you.
Then we can wind up, right?
Mm-hmm.
Purnima, you can call my WhatsApp if you want to. It's in
Sure,
the.
sure, Amol. I think you are completely busy, man. You won't answer my messages to you. You'll take time to answer my message.
Oh,
So
did you
I
send
thought
me
of
some message, but I didn't reply?
you took me one day. So I thought you were busy. I don't want to disturb you.
No,
So
no, that's okay. You can disturb me. I mean, I think I lost my job before COVID, and then I started a lot of tracks, and I
okay.
think I have to close down some tracks. That's my
Sure,
situation.
sure. I'm gonna call you on your WhatsApp.